Hello everyone, today is day 59 of solving a LeetCode problem every day, and today I'm going to be solving find target in rotated sorted array. So you were given an array of length n which was originally sorted in ascending order. It has now been rotated between 1 and n times. For example, the array nums 1, 2, 3, 4, 5, 6 might become this if it was rotated 4 times, or it might become this if it was rotated 6 times, which just brings it back to what it originally was, since there is 1, 2, 3, 4, 5, 6 numbers in the array. So given some rotated sorted array nums and an integer target, return the index of target within nums or -1 if it's not present. You may assume all elements of the sorted array nums are unique. A solution that runs in O of n time is trivial. Can you write an algorithm that runs in O of log n time? So the solution in O of n time would just be iterating through the array. You can just iterate through every single element, and then if it equals the target, then you can return whatever the indice is. The fact that it's asking us to write an algorithm in O of log n, and the fact that we have a sorted array, pretty much tells us that this is most likely a binary search question. So that's kind of the approach that I'm going to take. So of course we want to set our left and right pointers, and then we want to begin our binary search. And then, so we want to calculate our middle, so that's going to be left plus right minus left, and we divide that by 2. Now, of course, we have our base case, which is if target is equal to the number in the middle, then we just want to return whatever that middle indice is. Now, when we look at a rotated sorted array, so let's say we have 3, 4, 5, and then 1, 2. So when we calculate middle's going to be 5. And here we can see that 5 is greater than the very left element. So 5 is greater than 3. And what that pretty much tells us is that we're in the left sorted array of this array, if that makes any sense. So for example, this is the right sorted array, and this is the left sorted array. And the fact that 5 is greater than 3 tells us that we're in the left sorted array. The other possibility would be if it was, let's see, 4, 5, 1, 2, 3. So now when we look at 1, we can see that 1 is actually less than our very left pointer. So now we're in the right sorted portion of the array. So we can use this to our advantage. So we can say if nums at the left pointer is less than whatever the number in the middle is, we now have a couple possible cases. So let's say our target is 1, for example. So we find out that we're here at 3, 4, 5, and our target is 1. So we see that our target is less than our middle pointer. So what that's pretty much telling us is that if it's less than in our middle pointer, and we're in the left portion of the sorted array, then it could either be before the 5 or come after the 5. The reason why I say it can come after the 5 is because what we actually need to check is if the target is less than our very leftist pointer, because if it's less than our leftist pointer, then we know it has to be in the right subarray. So basically it's going to look like this. So we're going to say if target is less than the number of the left pointer, then we want to move our window to the right, since we know that we need to go into the right subarray, sorry. But then the other option is what if we had like 3, 4, 5, 6, 1, 2, and then our target is 6, and let's say we land at 5 at our middle, we see that we're in this left subarray, but our target is greater than our middle, which means that we need to go into the right subarray to look for the value there. So we can also say or target is greater than the value in the middle. And then for both of these, we just move our window to the left. Otherwise, or sorry, we move our window to the right. Otherwise, we want to move our window to the left. And it seems like I've been writing this code in the wrong place. I meant this here, and then here we return middle. And then of course we have our else. So the other option would be the fact that our number at the very left is greater than the number at the middle. So that means we're in the right subarray. So now let's look at this again. So let's say that the number we are looking for is 5, right? We see that 5 is greater than the very element at the right. So what that pretty much tells us is that we have to search this left subarray here. So we can say if target is greater than the number at the right, then we want to move our window to the left. So we have like 4. So if we're here and our target is 5, we want to move to the left. But then there is also another option, and it's the fact that, so let's say that our array looked like this instead. So when we land in the middle, we're at 2, and we know we're at the right subarray because 2 is less than 4. So what if our target was 1? So we also have to account for is if our target is less than the number at the middle. And in that case, again, we want to move our window to the left. So if this is our whole window now, we see 2, our target is 1, so we know it has to be to the left. So now our window is this. And then we just have our else, and we move our window to the right. And finally, we can just return -1 if the value isn't found. Now if we run this, it's submitted. So the time complexity of this is going to be log n. Since we're using binary search, we're exponentially decreasing our array size, or the search size of the array with each iteration. Then our space complexity is going to be constant. So yeah, that's my solution for the day.